So 22D is all about tables of outcomes. Tables of outcomes. We are going to have a stat box. Does everybody get their stat box? So tables of outcomes compare two categorical variables. So if you remember back from chapter 20, the categorical variables aren't necessarily like numerical. They're not like something you could measure. They're just like, they're like qualities, or different categories like types of music you like or what grade you're in or something like that. And we usually get these from a survey. So if you give out a survey and you're measuring different types of people and then different categories, then you can put all this data in the table. We do usually limit it to like the two different types of variables for our table. So it's a little bit different from normal. We've done this like a couple times. Your assignment is all, but we're going to do number one together. So number one is going to make up the notes, essentially. You can put it wherever you want. Like if it's in your assignment, I can't always, if it's on your notes, you can flip back and look at it. Like, I'm not really worried about that. Whatever place makes the most sense to you. Okay. So here's the question. We are going to add on to this table a little bit. I'll read it out loud, but remember it's straight out of your textbook, so you can have your textbook out. I highly recommend copying the table when you do your assignment. Well, I kind of tried to I can just mental math this and jot down a few numbers. That didn't really work for me, so I do recommend that you copy down the table when you work out these problems. A sample of adults in a suburb were surveyed about their current employment status and their level of education. So those are the two categories, employment status and level of education. The results are summarized in the table below. We got employed versus unemployed, so two different things that they could be in that category, two different categories there, and then attended university and did not attend university. You guys, why isn't my smartboard working? Okay, it's back. So we are going to add on a column and a row. So as you guys are making your table, leave space for this and we'll be filling it out together. So what we have to add are totals. So if I add the employed column up and I add up 225 and 197, it turns out 422 people are employed. Does that make sense? Then when I add up 34 and 81, 115 people are unemployed. When I add up straight across, 225 plus 34 gives me 259 people who went to university. And then 197 plus 81, 278 people did not go to university. Like, they did not go on to college. We still have one more space to fill out in our notes, but I don't want to rush through this too fast. Are there concerns? So I added the columns up for employed and unemployed, and then I added up attended university and did not attend university. So now I need to find the total number of people surveyed, and I can either add up this column or add up this row, and honestly I suggest add them both up because if they don't equal the same thing, you made a mistake somewhere. But when we add these up, we end up with 537, and so that's the total number of people surveyed. Okay, now I think that A, B, and C are pretty basic, though, but D and E are going to be like the tricky ones. So we'll probably breeze through A, B, and C, and then spend a little bit more time talking about D and E. I'm going to do my work up here, and I'm actually going to write out like what I'm writing down instead of just throwing numbers in there. So I want to estimate the probability that the randomly chosen adult, the next randomly chosen adult, attended university. So I have to put the total university over the complete total, all of the people. The total number of people that went to university over the total people in the survey. So again, attended university, if I follow this row over, that was 259 divided by 537. For most of these ones, since we can't reduce this fraction, we end up giving that decimal answer. We check the back of the book, and we have 0.482. All right, let's take a look at part B. So part B, we're finding the probability that the next randomly chosen adult did not attend university and is currently employed. So no university and employed. So I have to look for that sort of intersection. So they did not attend university, but they are employed, so that's 197. This one is still over the total. We're still looking at the entire population that we surveyed. So chances are if we looked for employed and no university, we'd have to take 197 divided by 537, which is 0.367. So far, so good? Alright, so then we go to part C. It just says is unemployed. So we need the total number of people who are unemployed. And again, we're still looking at that entire population. So you may have noticed in the past three problems, the total has not changed. So now I have to look at my unemployed column. The total number of people that are unemployed are 115. When I divide that out, I get 0.214. The next two are where it gets tricky. Are there absolutely any questions so far? So part D, question D, says estimate the probability that the next randomly chosen adult is employed given that they attended university. That other part. The other part of that question means we're not looking at the whole population anymore. We're only looking at the people that went to university. So when I set up my ratio, it's not over the total population, it's over the total for university. So that extra bit of information does change how we set this up. The first time I was reading it, I kind of didn't think anything of it, and so I didn't pay attention to that, but it is over the total university. So that means in our numerator, they have to both be employed and go to university, or went to university. So they have to be both employed and university, but I'm only looking at the part of the population that went to university. So I would have the total university, so that's 259 in the denominator, and employed and went to university, which is 225. So using that information, why don't you guys try part E? Keep in mind there's some more info there, given that they are unemployed. So taking a look at how we did D, I'm going to give you guys a couple minutes to see if you can work out part E on your own. So what did you guys get for your decimal? 296, 296, I saw 296 back there. So if you did not get 296, make sure you listen up. You know, since it says estimate the probability that the next randomly chosen adult attended university, given that they are unemployed, means, again, we're not looking at the whole population of the survey. We are only looking at the unemployed. So that would be total unemployed. So then what I'm looking for is that they went to university, but they are also unemployed. So then I've got total unemployed is 115, went to university and are unemployed is 34, and that's how I get that 0.296. So these last two, we just kind of need to talk about what those words mean. I do think this section is pretty basic. Are there concerns at all? Okay. And then we're just going to do the stat box and we're done. I did not know how to word the question I wanted to, so I kind of put two different ways to word it. So what does it mean when the probability says given that? Or another way to ask that question I'm trying to get at is, how do those problems differ from questions that do not include given that? I don't think we need to discuss this together. Wait, you want to? Oh, okay. I was going to say, we don't need to discuss it, but you need to remember it. So I would jot something down just because that was probably the most confusing part of this section. Remember, the assignment is all. Also remember that we will have a quiz this week, so don't put off your homework.